Alright, my testing. I hope you guys can hear my voice. Hello guys, yeah, I hope you guys can hear my voice and I hope you guys already download the notes. And yeah, this year I actually pay some designer to actually help me to make my note look nicer because last time actually I draw it myself. So yeah, I hope you will like the notes I designed. Alright, okay, this is a trial class for the Score A masterclass. So yeah, so today we're going to teach about function, and function is basically the for the first chapter. Okay, before we go into the function, yeah, we have a lot of things to talk about today. But before we go into the function, let's discuss a little bit like what's this function. Okay, what's this function? Okay, because in this topic you need to know what is function. It's not like the philosophy or what. Okay, so in this topic, right, they define the function is something like this. It must be y power of 1 and the x can be any power you want. It can be power of n, or it can be power of square root of 1 over 2. It can be power 2, power 3, power 4. So whenever we call it as a function in the equation term, right? Let's say, I think you heard about quadratic function. When we call quadratic function, do you see the word function? This word, it means is y equals to ax squared plus bx plus c, right? I'm not sure you heard about linear function. Linear function. Linear function, we also have the keyword of function, isn't it? Is y equals to ax plus b or mx plus c. It's the same thing. And then, of course, I can still give you a lot of different function. We can have cubic function, and then we can have any polynomial function. Yeah, we can have polynomial function. So over here, all these functions, they have something in common. Cubic function is ax cubed plus bx plus c plus bx squared plus cx plus d, and then this is y equals to, yeah, it can be something ax power of n. So if you see carefully, whenever we call it as a function, the y is always power 1. So, but what does it mean by y is power 1? Okay, so this one you have to understand. Later over here you can see we have 4 types of relation. But before we go into that, right, you need to understand in the function normally we call fx. Okay, why do we call fx? Because this is x. It passing through a function called f. Then this one over here is called fx. But actually fx is equals to y. If you understand about the function, you know fx actually equals to y. So therefore this one I can call it y. Okay, when y must be power of 1, right, basically mean whatever x value you have, you can have a, b, c, 3x value, and all of them must link to one y value. Okay, this y value can be anything. Let's call it a k. Okay, so that means you can have many x value. If 3x value linked to one y value, this is the cubic equation because this one is x power of 3. And then this y is power of 1. Okay, but what if today I have a is x, I link to 2 different y value. This is what happened is, this is called 1x and 2y value, right? So you can see this is y squared. So whenever you have y power is not 1, then normally we doesn't call it as a function. Because if you want to call it as a function, right, y must be power of 1. Okay, this is something is very important because sometimes you might have y square, y cube, square root y. You have different power of the y is not considered as a function. Okay, as long as y is power 1, I don't care what is your x power. Even though you have something like square root x plus 1, this one we still consider it as a function because y is power of 1. Okay, so therefore it's over here. If you see the 4 type of relation here, 1 to 1 is a function because y over here is because y over here is 1. Why you like to use a black background? I don't know. I just love black color background a lot. Even my phone also I changed to dark mode. Alright, so yeah, so you can see when we call, because this one you can see one x value linked to one y value. This one you can see I have 2 different x value linked to one y value. So we call many to 1. So the many here actually stand for many x value. I can have x1, x2, x3. Can I have 10 x value linked to one y value? Also we call many to 1. The 1 over here we change, we means the y value. So 1 to 1 means 1 x value linked to 1 y value. So like 1 to many is what? 1 x value linked to 2 different y value. So this one is something like, so is in equation form, this one have some y square, or you can imagine you have many y value. So actually it's just mean the y square in this case. Y square, I mean, why do I write x square? So this one is many to many, mean you can have 2x value linked to 1 y value, or 1 x value linked to 2 y value. This one can be something like x squared and y squared in the equation world. So this one is, it can be x squared, it can be x cubed, it can be x power of n. So it's called many to 1. So it's over here, if you understand what I'm talking just now, at least you need to understand when we call it as a function, it's only for the first 2. Okay, only this one is a function and this one is a function, because you can see both of them only link to 1 y value, and bottom these 2 is not considered as a function because you have y square, you have the y more than 1 here. Okay, so I watched your integration solution for 2022 Major Cambridge IMF, very helpful. Yeah, you're most welcome. Yeah, I also teach the IGCSE MF tuition also, but the one I'm not using YouTube Live, I'm using the Zoom. Okay, but a lot of students, okay, now you kind of understand about the what y power 1, y power 2, or x squared or x cubed and so on. So I want you to understand what happened when this kind of x power or y power, when you go to the graph, because in SPM exam they might give you a different graph pattern and ask you which graph is actually function and which graph is considered non-function. So you need to have a little bit idea of the graph. So here I also prepare you some graph here. So you can see the 1-to-1 function, right? The most common one is a linear graph. The linear graph, that means 1 x value basically will link to 1 y value. So you can see, yeah, this is a straight line graph, or y equals to mx plus c. Sometimes I will call this one y equals to ax plus b. It's the same thing. An exponent graph also considered is 1-to-1. Or sometimes you might have the square root graph is also the 1-to-1 function. Or this one we call reciprocal graph. This one we call reciprocal. This one we call exponent graph. Is 1-to-1. This one we call square root graph, or x power half. So all this graph is basically considered 1-to-1. Okay, later I will explain further about the graph using something which is the love is called horizontal line test. I believe you should read this one in your reference book, or some reference book they call vertical line test. We have a word test here. So when play chess with me. So right now our Discord can play chess already. Yeah, can try to play. Last time my chess, I was quite very good at the chess. I remember when I'm Form 3, I got number 1 in my school. But it's many years ago. I didn't train my chess for quite some time. I think now my chess is actually quite no. But play for fun, I think is okay. Teacher, your videos for vector damn good leh. I'm so sad I never watched before the exam. Then you should start watching. Oh, I think you already finished the exam. Then at least you can recommend to someone else. Okay, then we call many to one. Okay, many to one you can see. This is quadratic graph, quadratic, cubic, and sine graph. All these are many to one. Yeah, even y equals to sine x. Also, we call this one as a function because it's y power one. Okay, but what happened when y is not power of 1? You can see these two is considered non-function, right? Both of these we call it non-function. So over here you can see the pattern is this is y square graph, this is y cube graph. This is a circle, x squared plus y squared equals to r squared. This is oval class, the oval graph. This graph I believe is something like x squared over a squared plus y squared over b squared equals to 1. You don't need to worry about the equation. I don't think you will see this kind of equation in SPM syllabus. Okay, so yeah, at least you already see these two pattern of the graph is a function, and these this few pattern is not the function. Yeah, they call ellipse line, not oval. Yeah, thanks for that. I suddenly cannot come out this word in my brain. Yeah, thanks for David for telling me that. Okay, so right now what we want to do is we want to do the horizontal line test. Okay, when we call one-to-one function, right? That's mean, let me choose a nice color. Let's choose some green color. Is it green color? Okay, good. That's mean horizontal line. What does it mean by horizontal line first? Horizontal line means that line must, if this is x-axis, right, the line must be parallel to x-axis. We call horizontal line. And vertical line mean if this is y-axis, the line must be parallel to y-axis. We call vertical line. So for horizontal line test here, it actually means if I draw a horizontal line, I can only touch one point for my x or y value. So you can see if I do horizontal the horizontal line test like this, you should be able to see I only touch one point. So and then I test like this, I only will touch one point. So for the horizontal line test, if you can touch one point, basically means x is just power of 1. If for horizontal line test over here, let's say I touch 3 points, this will actually mean x is power of 3. Of course, the graph can go much more complicated than this, but you don't need to know until so detailed. But let's say today I do the horizontal line test. I touch 3 points. Means what? Mean many x value to one y value. So this one can be x1, x2, x3. So in short, we call many to 1. So over here, if I do the horizontal line test, right? If I do the horizontal line test, you can see how many horizontal line I draw, right? I will only touch 1 point. Okay, so if I do the vertical line test, right, you can see I also touch 1 point of my graph. Right now, you should focus on the red color line. So that means I only touch 1 point. Same idea to the y equals to ex graph. So if I do the horizontal line test, you can see I touch 1 point only. I touch 1 point only. No matter how I do, also I touch 1 point. But if you see the many to 1, many mean many x point, you can touch many x to one y over here. So if I do the horizontal line test here, you see how many x value I touch? I will touch x1 and x2. if for the sine graph, you see how many x value I touch? 1, 2, 3, 4, 5, 6. Yeah, for sine graph, actually you will touch infinite x value. So for this one, is many to one, because you realize if I want to know how about the one, how do I get the one idea? Mean you do vertical line. If you do vertical line, you realize I only touch one, isn't it? No matter how many vertical line I draw, I only touch one value. That means this is how I get the idea of one. Okay, here you can see I draw a vertical line. I only touch one point here. Do you see that? But if I come to here one to many, if I do the vertical line test, do you see I touch two value here? I mean, two different point here from the graph. So this one we call one to many. But how do I get the idea of one? Because this one means one x, right? In order to test the x, we do horizontal line test. In order to test the y, we do the vertical line test. So if this one I do horizontal line test, you see I only touch one point no matter how I draw. Okay. Then we go back to the many to many. So if I do the horizontal line test, I touch 2 points. If I do the vertical line test, I also touch 2 points. Do you see? This one is called many to many, because this one I do vertical line test, I touch many. This one I do horizontal line test, I also touch many points. So this one is called many to many. Okay, so both of these is not considered as a function. So at least right now, I spend about 15 minutes to tell you what is function and what is not the function. You should at least understand some idea about function and non-function. Okay, non-function, in short, in a simple way to understand non-function is basically the y is power more than 1. Not to say more than 1, not 1, because y can be power half, right? Y power half is not more than 1. Yeah, this one is also considered a non-function. Okay, y must be power 1, then we can call it as a function. Okay, some student might wondering, sir, this topic is about fx, why you keep talking about y? Because fx, I can let fx equals to y square also, right? So if I say fx equals to x squared plus 3, this one, if fx equals to y squared, then this one is not the function. But because in the function topic, I know in the function topic, your fx is always y equals y power 1. But if you go to the higher level, we can call, no lah. Actually, in the higher level, the mathematician kind of fixed already, because fx stands for function, right? No matter it's fx or gx or hx, they're only used for y power 1. I think they fixed already. Because until I teach L level or SPM, the fx is always represent y power 1. But if I want to let fx equals to y squared, can I do it? I think I can't, right? Because when I write fx already, consider it is a function already, right? But this one I'm not 100% sure. So okay, so but at least I know for non-function y power is not 1. Okay. Bye bye, sir. Actually, right, I finished my IGCSE MF already. I just want to say thank you. Thank you so much for the video, and keep making them. Yeah, most welcome. SPM is so close. SPM is still have some time, right? Because SPM I believe in February. Alright, so no, I think SPM should be February next year. Okay, so right now you need to know 4 type of relation. I mean the name, because in the exam they might ask you just 1 mark question. They will ask you what is the type of relation for this function, or what is the type of relation for this equation, or what is the type of relation for this graph. So at least you need to know right now you have 4 type of relation: 1 to 1, many to 1, 1 to many, and many to many. So these 4 type of relation, you kind of need to memorize it, and then you need to understand the 1 to many. Whatever they say first one is x, they say after will be the y. Okay. Alright, then okay, we come back to some basic thing now. Okay, over here you should be able to see this thing. This thing is kind of boring. It's something like you need to memorize some words. So over here we have some domain, and then we have some subdomain, or sometimes they don't call subdomain, they might call it as a codomain. It's the same idea. So whatever inside the domain we call it object, and you already know domain is for x, and then we will pass through the function. Function can be f, can be h, can be g. This is a common word they use. Of course, I believe they can use much more than that. And then you over here, let's say they use f lah, so there will here will be fx. So the whole fx thing we call subdomain, or we call codomain. Okay, so whatever element, this one, all this inside they call element. Whatever element inside the subdomain one we call image. Okay, but over here you can see for all the image here, when he linked to my x1, when he linked to my object one, we call range. Okay, so you can see over here 5 and 6, it doesn't link to my object, isn't it? So my range over here is not include the 5 and 6. Okay, but this is all the image I have. Okay, but over here, this is quite simple. But over here, got something you will see later in this topic, which is you need to understand what is the meaning of domain and range. Okay, so this is something in CAD SSM is something I would say is very important here. So let me explain further a little bit on the range and domain, because a lot of my students, they until Form 5 they still do not understand this. Range and domain last time is not so important in SPM, but when you go to university, range and domain will play very important role. Yeah, and then you will even use a set notation to actually write the range and domain. But right now I don't want to cover so much, but I give you some idea about what's in range and domain here. Example, I have an equation fx is equals to maybe 3x plus 5. Okay, I give myself, okay, sometimes they will use line to represent it. It's the same idea. Let's say I write a 3 here, I write a 3 here. It's the same idea, but sometimes they will use line rather than circle to represent it. Okay, so let's say my x value is 3. How do I get my fx value? Let's say I pass through a function f. So basically, I just need to do f3 here. f3 is basically equals to 3 plus 5, isn't it? Then I will get about 40. Let's say I do a 10 here. 10 is basically f10. So it will be 3, 10 plus 5. So this one should be 35. Okay. You can see over here I can say my range, my domain, I will have basically 3 and 10. And my range, I will actually have 14 and 35. I say range is in the subdomain when he linked to the object. When the image is linked to the object, that value we call range. But in the graph world, let's see what happened. So if I want to draw out this thing, you should be able to understand 3 and 14 is a coordinate. Because like I say, this is x, this is the y. That means the 3x value will link to the 14y value. So this one is the coordinate. So therefore, another coordinate is 10 and 35. Teacher, I'm always confused about domain and range. Yes, this is the reason why in the first class, I actually want to give you guys some idea about domain and range. Because a lot of students, they even, before SPM, they still come to ask me, sir, can you explain again what is domain and range? So therefore, here I want to explain. Okay, 314, this one is just sketch. I just assume this is 3. The first coordinate here is 3, 40. This one will be 3, here will be 40. And let's assume this one is in 10 and 35. Okay, when we call domain, okay, right now we've only focused at the line you can see in the graph. Okay, this is x and y axis. You can see in the graph. Because this graph, right, if based on my eyes, I see that domain is the range in the x value. Range is the range for the y value. So basically, here is my domain. So my domain, I use x to represent because it's a range for x, isn't it? So you can see my domain is between 3 to 10. Some student might say, sir, why can't I do 3 to 20? Because right now, from what I can see, the x actually stop at 10. Because you want to go 20, your line need to extend to 20, isn't it? But from what I can see from my graph, my x is only 3 to 10. Some student might ask, sir, why can't my domain be 0 to 10? Because you can see my x value start at 3. I doesn't have any line before 3. I doesn't have any line before 3. So therefore, my domain is from 3 to 10. Yes, domain is for the range of x. Is x. Then right now we go to the range. Range is for the y. It's the same idea for domain, but for the y. So range over here, from what I can see from my graph here, is from 14 to 35. You can see my line, the y value is from 14 all the way to the 35. But in the function topic, they will never use the 35 to represent it. They will use they will never use the y to represent it, the range. So normally in the function topic range, they prefer use f to represent. So my function is 14 to 35. If this is fx lah, let's say today this is gx, then the letter I write at the middle will be g. If this is hx, the letter in the middle of range must be h. It's between 14 to 35. If the function is hx. Okay, you get the idea, right? The middle letter will change depending on how they write the function. Is gx, fx, or hx. But for domain, no matter what is the pattern, domain is always x1. They always use x to represent the domain. Okay, so here you at least you get some idea about range and domain. I want you to understand. If you don't understand, please feel free to ask in the comment section. This is the reason why you want to join live, right? Or else you can just go to subscribe my 40 ringgit. You can watch almost all the topic I teach last year. I believe last year I covered all the topic for the SSM syllabus, Form 4 and Form 5, every single chapter. So if you don't need to join live, you just need to pay the 40 ringgit. Okay, so but let us make this thing slightly more interesting here. Because straight line is so obvious, we can easily see the range and domain, right? But what if it is not a straight line? Let's say, today I give you a quadratic. From -3 to 3. And then here, I give you some random value. This is 5. I don't want it to be same length. Same length is very boring. I want it to be something like this. Quadratic. And then this one is 12. Okay. So right now, if you want me to write the domain for this graph, I know my x must be between -3 to 3. And my range, let's say this is gx. My range, my g will be between 5 to 12. Do you see? This is my range and this is my domain. Okay, I want to make it even more interesting. Yeah, because you might have the different pattern of the graph and then ask you about range and domain. I give you some modulus graph. This is -1, this is -2, this is 5, and this is 3, and this is 10. This is x, this is y. Okay, let's say this is my modulus graph. So if today I want to write my domain, I want to see my whole graph is between -2 to 5. It's quite easy for domain. But for range, you can see my whole graph over here. You build a lot of students see, oh, I can see, let's say this is the hx. I say my h is between 3 to 10. If you write like this, right, you got wrong. Because why? For the y value, right, you can see you do have the graph below 3. This is the problem. If you say your graph is only 3 to 10, right, you are telling the examiner your graph is only here and here, which is only 3 to 10, right? But in fact, you still have a small part over here, isn't it? At the bottom, below 3. So therefore, your range over here is actually from 0 all the way to the 10. Because my range should be everything of my graph, isn't it? This is my range. The y is from 0 all the way to the 10. Okay? So yeah, here I actually provide you the few different pattern. Quadratic graph, how to see range and domain. Linear graph, how to see range and domain. And even modulus graph, how to see range and domain. I don't know why I do differentiation can use until modulus. Maybe in a higher level you have something like that. But I seldom see differentiation together with a modulus. Okay, so okay, right now at least you have some idea about range and domain. Okay, let's come back to this thing. What if they ask us to find a range and domain, they give us some domain and subdomain, like two circles here. Let me add some value at the middle. Let's say I have a value 5 here. Okay, so for f5, I should get about 3, 5 plus 5, which is 20. So I will have a 20 here. And you realize this one is also a coordinate 520, right? So this 520, they will not affect your range and domain here because of what? 520 is just a coordinate at the middle here. So you have a coordinate 520. So if in this kind of diagram, right, if I want to take the range and domain from here, I will take the minimum of the x value and maximum of the x value as my range and domain. So therefore, you can see, let's say I want to write my domain. Of course, this one is in the graph world, because in the question, if they ask you to write the domain, you kind of need to write all the 3, 5, and 10. But if they want me to write the domain in the inequality form, I will take the maximum x, this one will be minimum of x value, and maximum of the x value. So same idea, if they want me to write my range in the inequality form, I will take the minimum of my y value and maximum of the y value. But like I say, this is not always the case. Why? Because sometimes when you solve it, right, you might not able to see the minimum or maximum. So this is just in the some case you can apply this thing. But okay, do not want to use this because I worry some students when I tell them that, right, they will just use this at any cases. Anyways, the range and domain we will cover more in the future because it will become much more complicated when inverse function come in. But if inverse function doesn't come in, then it should be fine. But in this case, yes, we can actually straight away use the minimum and maximum for the one-to-one function. But when you go to the many-to-one function, right, yeah, sometimes you cannot use it. Okay, let me explain, because some students, after they listen to me, they say, sir, I have no idea what you're talking about. Give you a random example. Simple one can already. Y equals to x squared. Okay, this one is many to one. How do I know this one so fast? Without doing horizontal line test or vertical line test. Because I see x squared. When I say x power 2, basically mean you have 2x value. X power 3 basically mean you have 3x value to 1 y value. So this one is basically many to one. Or let's call it fx. Okay, because a lot of students, let's say I give you the domain. I give you a domain and ask you to find range. This is quite similar to the exam question. I say the domain is from -2 to 5. example. This is just a random example. And a lot of students, when they want to find a range, right, they will be very smart. They understand domain is x value. So they will just put -2 and 5 here. And definitely you can insert the -2 really fast here. And then you can insert the 5 very fast here because x squared, right? 5 squared. So this is 25, this is 4. Then the student will come to the conclusion. They say, sir, I found it already. My range for f is between 4 to 25. And they are so happy about this, and the idea is one of the value is correct, but this range is wrong. Any one of you know why it's wrong? Why this range is wrong? You guys been talking a lot, right? Let you guys got some time to think. Which part got wrong? Okay, if this one is not the one-to-one function, right? So you cannot just simply take the minimum and maximum value. So this is the reason why just now I erased my the so-called shortcut methods. So if I sketch out the graph for x squared to give you some idea what's the x squared will look like, I think I might be the one who did the wrong answer. Yes, it's very common because this is one of the common mistakes a lot of students make. Because if you understand the graph of the x squared, it should be something like this. This is the graph of x squared. So you can see when this is -2 and this is 5. And based on my finding, -2, I will get 4. 5, I will get 25. And then you trying to tell the examiner, I already found the range. The range is here only. My f is between 4 to 25. But the problem is, if you see carefully, your graph should be all the way here, isn't it? Your graph should be between 0 to 25. This is the correct one. So what is the... Okay, the Jonas Wang actually says a very good point, because this is parabola graph. When this is parabola, or yeah, some students don't get used to the parabola, this kind of keyword. I just call it quadratic graph. When this is a quadratic graph, what we need to do is we always need to find the minimum point first. We need to know where is the minimum of the graph. This is what do I mean by minimum. Because without knowing the minimum, just purely substitute the value and decide the range. This is something quite dangerous in function topic. So, then student will ask me second question. Sir, how to get the minimum graph? How to get the minimum coordinate or minimum point? There's two methods I can tell you. The simple way, you need to learn chapter 2 first. I'm not sure how many of you already learned chapter 2 quadratic. You need to do completing the square. Completing the square. Yeah, if you never heard about completing the square, it's fine. It's basically fx will be ax minus h squared plus k. You need to make your equation into this pattern, method number 1. This is how to get a minimum. If you are from 5 student, you learn about differentiation already, right? If you are from 5, I think it's from 5 first few chapter, then you can do dy dx equals to 0 to find your minimum point. Third, if you haven't learned quadratic, you haven't learned differentiation, how you can do is you can use my Casio calculator, 570EX or 991EX. Okay, but this is a bit tricky if you want to use a calculator to sort of know the minimum. Okay, I have an equation y equals to x squared, right? So you should know general equation for quadratic, right? Is ax squared plus bx plus c. So in this case, I only have x squared means what? mean my A is 1, my B is 0, my C is 0, right? Because you can see 1x squared plus 0x plus 0, we call x squared only, right? So I will insert my menu. I go to the equation, which is the A here. I enter, I choose polynomial number 2. This is power 2. So A is 1, my B is 0, my C is 0. So if I type the equal here, you can see they tell me my minimum y value is 0. Do you see that? Minimum y value is 0. Definitely minimum x value is 0 also lah. If you see carefully, minimum x value is 0. So this calculator can tell me my minimum coordinate is 0, 0. So after knowing minimum is 0, 0, it's easier for me to estimate. So from the range value I find from my finding here 4 to 25, I know one of it must be 0. Another one I will take the maximum one, which is I take 25. Then I know it's from 0 to 25. Okay, but this one is a more complicated way of range and domain. Teacher, is this a must for us to draw out a graph to answer it? I would recommend most of the students to draw it out. Unless you can visualize or unless you already get the idea, then you can just do it without drawing it out. Because now if you want to draw out, we have a third problem. Many of the students are not able to draw out the graph. Because right now is y equals x squared is simple. But the quadratic equation can get much more complicated, right? And normally range and domain in the exam is just 1 and 2 mark in SPM. So if you want to draw out also can. If you don't want to draw out, it's fine also. But no worry. When after finish all the tutorial, definitely we will go to see a lot of questions together. So I want to make sure most of you, if you join my masterclass, can fully understand it. But here, at least I give you some idea is not all the time you can just sub your x value into it to find your y value and straight away tell the examiner that one is your range. Because like I show you, in this case, if you get 4 to 25, you might not get the full mark. Maybe 25 you will get 1 mark from there. Okay, you must be very careful. Okay, so until now, it's about 45 minutes already. I hope at least you get something. First, you can identify what is function, what is non-function, and then you already memorize what is the type of relation, which is 1 to 1, 1 to many, many to 1, and many to many. And then from there, you at least you get the idea about what is x squared, x cubed, y squared, y cubed. How to identify from the graph, from the diagram, and from the equation. Okay, so this is something, it's a very important foundation for function. Okay, then after that, range and domain is something I hope you understand. Okay, so if you understand all these things already, definitely you might, because sometimes I speak quite fast. So you can slow me down if any part you don't get it, or you can just rewatch this video, because after the live streaming, this video will automatically upload to the YouTube, so every student will be able to watch it. But because I mean tomorrow onward, because the masterclass start tomorrow, right? If you join for modern math, yeah, I will set the setting from public to the member only, so that only students who join the member can watch the content. But no worry, because some students are so panic. Oh my god, I'm from a very poor family. I don't have the money to join a masterclass. But I have more than 700 videos in my YouTube channel. All the students can still watch for free. So if your family financial have issue, means you don't have 40 ringgit or 100 ringgit for tuition fee, feel free to watch my free content. I think my free content is more than enough for you to actually score well in your MF. So yeah, because some students will think, sir, I really want to join, but I have no money. What can I do? I always recommend them to go to watch my free content. Even I know a lot of very good math and MF teacher in YouTube. They do make a lot of content for free. So poor is not an excuse to make you success in math and MF. Okay, so after all this domain, okay, all the boring things done already, then go to my favorite part. It's about algebra of the function. Because I love about function, because okay, first thing is My algebra is very good. If you have very weak foundation in algebra, trust me, go to sharpen it, because you need a lot of algebra in MF and even math. Okay, this is a favorite keyword for exam. So if one keyword you must memorize in this topic is this one, map onto itself. Because come out in SPM exam multiple times, they will say, yeah, the function map onto itself, ask you to find A, B, C or K or something, find some unknown. So over here, let's see this question. Let's say I have a fx is 3x plus 8, and then find the value of x when the fx map onto itself. This is what the exam will ask. So map onto itself basically means what? In the graph world, it means x will map into x, or 5 will map into 5, or apple will map to the apple. So that means it's going to map onto itself, but only one of it lah. Here I actually show about 3 example is actually not so good. So in this case, I know x will map into the x, right? But this is the y, this is the x value, and this is the y value, or y value at the same time is the same idea of fx value, right? Basically means what? Mean your x will same with your fx. Because your x right now is x, your fx right now is fx. So therefore, my fx is 3x plus 8. Since fx will equal to x, then 3x plus 8 will equal to x. So by solving this equation, I know 2x will equal to negative 8. Then x will equal to negative 4. Okay, I believe this part a lot of students can understand because it's simple algebra. But if I get x equals to negative 4, what does it mean? That means in this question, if my x is negative 4, I guess later my y value or my fx value will be negative 4. So let's see. If x is negative 4, my f negative 4 will be 3x plus 8, right? 3 negative 4 plus 8, negative 12 plus 8 is negative 4. That means in this function, we'll have one value mapped onto itself, which is when x is negative 4, my fx, I will get negative 4. Do you get the idea about map onto itself? But of course, the function not necessarily must be the linear function like 3x plus 8. It can be more complicated function. But at least over here, you need to understand the idea of map onto itself, because it's a very simple idea and they give 2 to 3 marks in the SPM exam. Okay, so here I actually provide you the example. Okay, then before I go into the composite function, I want you to understand how to sub the things, and I believe here I actually missing some part here. Yeah, this one is very important. This is very basic, but I worry some students just have no idea. Okay, so sometime they will ask you to, let's say they ask you to find the image of 3. Okay, so find the image of 3 basically mean this is 3 is the object. This is the object, right? Like what I say. And image of 3 will be 10. Okay, this is the image of 3. So same idea. They ask you to find the image of 10. So this image is 10, right? You want to find already, your object will be 3. But what I want to say is not only this. Example, if I have the fx equals to x plus 7. In fact, I write the equation because sometimes in the exam they will ask you to write the function for this diagram. Then it's x plus 7, because you can see when f3 I get 3 plus 7, I will get 10. And if only have like one object and one image. Is it the only function? No, I can write fx maybe can be 3x plus 1 also can. Because as long as I sub the 3 into it, I get 10. Then it should be fine. Okay, but here I just use a simple equation, x plus 7. Okay, so here, what I want you to understand is sometime in the exam, they will say this is A and this is 10. And then they ask you to find A. So, over here, you need to understand, if I want to find A, right, this is the value for fx. So that means I need to sub 10 into fx, and then by solving this equation, I get x equals to 3. Do you get the idea? How to sub the value from the diagram to your equation? Okay, same idea. If today they tell you this value is k, ask you to find the value of k for this equation or this function. So you should understand this value is fx, right? And this value is x. So what do I do here is, sometimes I will write like this. I'll write f3 equals to k. Because what? My x right now become 3. And my fx right now become k. And then only I solve it. I know f3, that means that all the x here need to change to 3. So 3 plus 7 equals to k. Then my k is equals to 10. Okay? I hope you understand how the substitution work here. Yeah, because sometimes it kind of confuse. Sometimes they will use the word image or object to confuse you. I think here got some typing error. I think here is got some typing error. Oh my god. 10 is the image of 3. And 3 is the this word is object, sorry. Yeah, whoever got this note, change this word to the object. Yeah, 3 is the object of 10. Yeah, I'm wondering how come both also is the image. So do students need to explain why FGX exists? I don't think SPM will ask something like this. Want to explain FGX exists? This is more on the pre-U math. Or maybe your Singapore math will ask about this. In SPM, I only see they ask about explain the inverse function exists. But I sell right now, maybe the question I see is not many enough. I mean not, yeah, I need to see more questions. Because so far, I haven't seen they ask the student to explain the composite function exists or not. Yeah. Okay, so therefore over here, I do a very cute thing over here is about the substitution. So right now, because before I go into composite function, right, I want you to understand I can substitute anything into all the x here. You see, I can substitute the 2k, then the whole equation will, all the x here will become the 2k. Then I can just expand the 2k to actually get, this one should be 4k square. Some error over here. Okay, I will tell my designer to change it. Okay, so yeah, so you can see after I expand already, I will get something like this. Or I can even substitute k cubed into my x, then my whole equation will become something like this. Or I can even substitute some cartoon here into all my x, then then the whole equation will be, I'm not sure what is this. Is it a crystal? I don't know. So it becomes a crystal square minus 3 crystal plus 1. Okay, so if you understand I can substitute anything into x, then I can make the thing more complicated. What if today I substitute gx into it? Then let's say gx is equals to simple one lah, x over 2. Let's say my gx is x over 2. I substitute into my fx. Then it become what? The f, this one will become gx, right? Then whatever thing on the other side, the x, this one will become gx squared minus 3 gx plus 1, isn't it? But okay, when I sub one function into another function, they call it composite function. Okay, it's just a name. It's just a name. You don't know the name also is fine, but it joined together composite function. So composite function, they have a rule is on this side, right, on your right hand side, they will not write the gx into it, but they will write the equation of the gx, which is x minus x over 2 into here. So normally I will do like this. When I have the x, right, I need to sub the gx into it already. So the equation is x squared minus 3x plus 1. Then I will say whatever x, I will just put it as an empty bracket. X squared minus 3x plus 1. Then only I ask myself, what is gx? Gx is x over 2, isn't it? Then sub into the bracket. Then this one will be x squared over 4 minus 3x over 2 plus 1. Do you get the idea? If today I say my gx is some random one, I don't know, it's square root x, then I will do the same thing here. Because the bracket can be anything, depend what is the gx. If the gx is square root x here, square root x here, then this one become x minus 3 square root x plus 1 is my final equation. Do you get the idea? But what if I make things more interesting? I sub fx into the gx. Become gfx. My gx is square root x, I remember. So I will write the square root. My x, I'm going to put a bracket. Because when I sub fx into gx, I'm writing the gx here. I'm writing the gx here. Gx is square root x, right? Square root x. But x, I doesn't write anything because I know right now my x right now is a fx. Then I ask myself, what's in fx? Fx will be x squared minus 3x plus 1. So this one will be the final answer. Okay, so I want you to think about this because next week we will go much more question and example about the composite function and inverse function. But that's all for the class today. So today I will just stop here because normally each classes I will just plan about tutorials about like 45 minutes and 15 minutes is for you to ask a Q&A or we can see more type of questions. Yep, anything you want to ask me before I end the live streaming today? And thanks Elvin for passing by to help me moderate the chat room. But normally masterclass are fine. The student here, I think they are okay. Singapore MF no function. But H2, yeah, H2 math is for A-level math, isn't it? Good questions. Yeah, some students ask about what Polga asked about it. X over A plus Y over B equals to 1. This is the intercept form of linear equation. Linear equation. In short, A and B is X. A is X intercept and B will be Y intercept. In order to make the Polka to understand this one, I give you an example. X over 2, Y over 5 equals to 1. If I want to draw out this straight line, linear graph means straight line, right? I can very fast to get it. This is 2, this is 5. So this is the equation of my straight line. You can see x-intercept will be 2. That means the line will touch the x-axis at 2 and will touch the y-axis at 5. Teacher, may I know, does teacher give us this note or only the member will get it? Yeah, definitely this is a note I prepare for all my masterclass students. So kind of only will give to the member for supposedly lah. This one will give to the member. But since today trial class, right, I want all the people who attend this class to get this note. So I actually share the link for this material. So yeah, you can get it for free for this chapter. Yeah, but for the following chapter, you might need to join a member in order to get it. Alright, I hope I answer your question, Mandy. Alright, so any more question, or else I will just end the live today. And yeah, so for I believe Tuesday, Wednesday, and Thursday night also we have the class for modern math and MF, and Thursday is for the Mandarin version. I'm not sure how many students want to join the Mandarin version of MF. If really too little students want to join that, maybe I will cancel that class. Same idea to the master class. I'm not sure have a lot of students interested to join this master class or not. If until end of this month I have like more than 20 students, then maybe next month onward I will not do the my master class also. So yep. So how to do gx equals to 5x plus 1 and hx equals hx plus x squared minus x plus 3. So for Kartika, maybe you can post the original question to the Telegram. Yeah, I guess all of you has my Telegram account, right? The study with Matthew. You post the question over there lah. Then I will try to reply you over there. Alright, so okay. See you guys around. I hope more students will join this masterclass. So I will see you guys around at my YouTube channel. Thanks for attending this masterclass. And thanks for your time stay until the end. We have about 26 students stay until the end. Okay, I will see you guys around in my YouTube channel. Bye bye.